Hello and welcome back to the channel. Today's video answers one of the biggest cosmic mysteries. How did the moon form? The moon has guided calendars, tides, navigation, and human imagination for thousands of years, yet its true origin remained a puzzle for centuries. Ancient civilizations created myths about it, scientists debated it for generations, and even modern astronomers struggled to explain it. But thanks to space missions and samples brought back from the lunar surface, we now know the moon's birth story involves one of the most violent events in Earth's history, a collision that changed our planet forever. For a long time, scientists believed the moon may have formed alongside Earth as a twin, or that it was captured by Earth's gravity as it wandered through space. Others proposed that a rapidly spinning early Earth may have flung off a chunk of its crust that later became the moon. Although these theories sounded reasonable, none could fully explain the moon's unusual size, its stable orbit, or the chemistry of its rocks. The real turning point came when astronauts from the Apollo program returned with samples that allowed scientists to study the moon directly for the first time. Today, the most widely accepted explanation is known as the giant impact theory. According to this model, around 4.5 billion years ago, a Mars-sized object, nicknamed Theia, collided with the young Earth. The impact was unimaginably powerful, releasing more energy than any volcanic eruption, earthquake, or asteroid strike in history. Molten rock, vaporized metal, and debris were blasted into orbit around the planet. Over time, this cloud of material cooled, clumped together under gravity, and slowly formed the moon we see today. When scientists examined moon rocks, they were stunned to find that their chemical fingerprint closely matched Earth's mantle, proving the two bodies share a common origin. But there was also a key difference. The moon contains very little iron. This suggests it formed mostly from Earth's outer layers, not from the iron-rich core. This explains why the moon is less dense than Earth and why its internal structure is so different. Later, computer simulations and detailed isotopic studies provided strong evidence supporting the giant impact scenario. The moon is not just a beautiful object in the night sky, it plays a crucial role in Earth's stability. Its gravity helps regulate Earth's rotation and tilt, which keeps our climate relatively steady. It also drives ocean tides that have shaped coastlines and may have influenced the evolution of early life. Without the moon, Earth could have been a chaotic world with extreme seasons and unpredictable weather, making it far harder for life to thrive. So the moon isn't simply a companion orbiting our planet. It's the result of a cosmic accident that helped make Earth habitable. If you enjoyed this fascinating journey into the moon's origin, don't forget to like the video, share it with your friends, and subscribe to the channel for more amazing space and science stories. Thanks for watching, and see you in the next video.